couple of images which has a connection with the computer network. So that if you are able to find the answer for this, you can answer in the chat. Okay, I hope. Can we go again? I hope the game is understanding, right? What I'm trying to say now. Can you please give the response in the chat? Make it fast. So I'll show you the couple of images. If you know the answer for the particular thing, you can, yeah. So you can answer it in the chat. Okay, I'm just showing the picture now. We just answer for this, right? Yeah. So what is this? Because if you know the answer for this, then I don't need to explore everything from the beginning. What is computer network? All this. Can you please connect this picture and tell me what is this? Any guess from the participants? I think around 50 people have joined in the Zoom now. Yes, anybody? Yeah, Srivani. Yes, it's the correct answer. Correct. The protocol, right? So in this session, we are just going to see what are the protocols are associated with respect to the OSCF things, right? We will also discuss about what is different types of protocol there in the network aspect. And then what is the next one? Yeah, just make it first because we are already delayed for 15-20 minutes. Even if it is wrong, no problem. But you have to connect this picture. Yeah, Nishant. Yes, Nishant is given a correct answer for gateway, right? Okay, we'll just discuss about what is gateway, all those things also. That's good. Okay, thank you for your prompt responses in the chat. Then what is this? Yeah, that's good. Saravana Kumar answered first. So bandwidth is answered and followed by one student named as a student. I don't know who is that. Okay, bandwidth. That's good. Yeah, then final one. What is this? Because if you know the answer for these pictures, then you are master in computer networks. What is the next one? You just predict the answer for this. What is given in the left? Yes, that's good, Shalini. That's the correct answer, right? So it is about wireless. Okay. So I think in the afternoon session, if we start this kind of things, that will be more interesting also, correct? Yeah. So these are the things we are just going to see more in detail with some real-time example. What is protocol and what is gateway, and then what is bandwidth, and then what is the difference between wired and wireless. Okay, so this is our agenda of the session also. So what we are going to explore in this session for the next 1.5 hours is that we are just going to discuss about what is routing protocols, and then what is the functionality of single and multi OSPF protocol, and followed by we'll be discussing more in detail about what is router, what is gateway, and then also we'll be seeing some of the research challenges which have been connected with this OSPF protocol. Okay, so this will be our agenda of the session, and then before that, we will just go through the definition about the term called protocol. Okay, so as you guys are aware, right? So if you want to exchange some kind of information from one system to another system, you need to use some protocols. So without protocol, you will not be able to connect with the system, or you will not be able to disseminate the information from one system to another system. So this is the definition about protocol. And then what do you have answers for the next image is that it's about gateway, correct? So gateway, which helps the users to or which helps the system to connect with the different devices. Let's say, for example, if I want to send my information, or if I want to disseminate my information from one system to another device, my system will be configured with a different set of protocols. Similarly, the other system will be configured with a different set of protocols, so that it just does the translator of the protocols. So according to the protocol specification, it will convert the everything as per the user need, right? So this is about the gateway. And then obviously in the computer network, this is one of the widely used parameter which we are looking in. It is about bandwidth, correct? So you know that whenever you want to set up a Wi-Fi network at your house, or if you want to launch a new internet connectivity from the service provider, we'll be just looking at what is the parameter we are looking in is about. It is about the bandwidth. So what here bandwidth defines is that it just tell you that what is the speed of your internet connectivity. Okay, so you, as you all guys are aware that the internet speed can be measured in terms of Mbps, Gbps, right? So depends upon the speed, the bandwidth also will be uh, used for the disseminating the information, right? And then here I just want to tell you about the difference between what is wired and then wireless. Okay, so whatever the things, I mean, whatever the devices which you are using for the dissemination of the information, okay, so that can be applicable for both wireless as well as the wired network. But here we are just going to see about what is the difference between wired and wireless, and what are the different protocols have been developed and implemented for wired and wireless protocols, right? So this is all about the general things which we want to know about. What is the difference between wired and wireless, and then what is protocol, all those things. Okay, so now we'll just move on to the next session of this seminar, that is about the OSCF protocol. Okay, so now we must understand the functionality of OSCF protocol, why it's been used, and for what purpose it's been developed, and what are the salient features which it has. Okay, so that we are going to discuss now. Okay, so if you look at this particular diagram, you can come to know that what is the different categorization of protocols. Okay, so we already discussed about what is the use of protocols, and then we already discussed about what is the gateway, all those things. Okay, so if you look at this classical representation, clearly you'll be able to understand that about the dynamic routing protocols, because in the protocol we have a different set of protocols. Some of the protocols will be much suitable for wired network, and some of the protocols will be best for the wireless network. Okay, but here all the protocols will have a unique feature of its own. So here not all the protocols are doing the same functionality here. Okay, so if you look at the OSI reference model, which starts from physical layer to application layer. Okay, so each and every layer, it does the different job of doing the thing. Okay, so if you look at this dynamic routing protocol, here we have two different types of protocol. One is about interior gateway protocol, another one is about exterior gateway protocol. Okay, so here what protocol we are going to discuss specifically, which is about link state protocol. Okay, so here in the interior gateway protocol, you just look at that. Here we have two different types of protocols. One is about distance vector routing protocol, another one is about link state routing protocol. Okay, so here the link state protocol only we are just going to discuss about the specific protocol, which is about OSCF protocol. So here the OSCF stands for Open Shortest Path First. Okay, so here the link state protocols, we have in addition to that, we have one more protocol, that is the IS. That means IS means intermediate system to intermediate system. So how your information is going to be transmitted from one system to another system. Okay, so in the next slide, I just show you the difference between the concept of routing and forwarding. So before we start up to discuss about what is OSF protocol, we must have clear understanding about what is the difference between routing and forwarding. Okay, and then just give you one real-time example. For example, if you want to if you want to make a travel from Chennai to Bangalore, okay, maybe from SRM to Christ University, you will be choosing an optimum path to reach out the campus at the earliest point of time. So that you will be looking at different possible routes to travel from Chennai to Bangalore to reach out Christ University campus, right? So you'll be collecting different possible routes. Among those paths, you'll be selecting the best optimum path to reach out Christ University campus. Okay, so this is the concept about routing the information. So here the routing is nothing but it's just going to select the best optimum path from the multiple paths. Okay, so this is about the concept of routing. Okay, so if you look at the OS reference model, maybe which starts from the physical layer to application layer, here the routing can be done in the network layer. Okay, so in the network layer only, all the packets will be disseminated or will be originated from source to destination through the shortest optimum path. Okay, and then if you look at the what is that forwarding thing. Okay, so forwarding is nothing but whatever the information is collected from one devices or one node, it's just going to pass the information to the other node. Let's say, for example, I hope this image is clear, right? Vignesh sir or Uday sir, can you please respond this, because this is fundamental things to
Yes,
know
sir. Yes,
about.
sir. Okay,
Yeah.
sir.
Thank you.
Yeah.
Yeah. So now you can look at this picture. I have given two pictures here, right? On the right hand side, you can see the number of nodes which has been placed in the slide now, right? Here I have 5 different nodes named as a source as S, and then followed by we have a node as a A, B, C, D like this. Okay. So here as a user, I'm just going to transmit some packets to the destination. Okay. And here, whenever the source wants to initialize the connection, basically in the OSPF protocol, it will establish the connection with one control packet. So here the control packet is nothing but here whatever the packet I'm using to know about who is my neighbor. So this is about the control packet. So to know who is my neighbor, I'll be sending the hello packet. Okay. So this is one real-time example I can give you also. Before you are becoming friend with one of your classmates or one of your relatives. So basically, you will be handshaking with a hi, hello message, right? And similar way here in the network context, we have a set of control packets to be disseminated among the all other neighboring nodes to know about who is your neighbor. Because if you are knowing the neighbors, then we will be able to send the packets to the destination successfully. Okay. So here, what now the source node does is that it just sends the packets to the neighboring node, and similarly here, the next node is keep on sending the packet until it reaches to the destination node. Okay, and here you have to understand one thing. Here, I'm just showing the only one path available here. Okay. But in the left hand side, in the first diagram, you can see that your device will be connected with a n number of nodes like this. Okay. But what our algorithm is supposed to do is that it has to select the best path among the all other available paths. So it is the ultimate aim for all the protocols to deliver the information seamlessly, right? So now you just come back to the so I just found out my neighbors, who are my neighbors of A, B, C, like this. Right? So once the D is received the information from the C node, and then the destination node will know that S is the source node of D node, right? So once it is identify the path, and then D node will send back the reply message back to the source node. Okay. And then what is the issue happening here in the previous thing is that you can see here, right? So once we identify the path here, then it has to replay back to the source node that it has been identified the path here, right? But when the transmission is going on, when you are trying to send some packets to the destination, so there is a chance of the link break. So what has happened to me for the last 15 minutes? Because I was not able to connect with the Zoom app for the last 15 minutes because of some glitches, technical glitches happened with my Zoom app as well as with my internet. Okay. So what is the main purpose of using this protocol is that we need to disseminate the information successfully without any error. Okay. Now here, what is the error is happening with this diagram is that now when the link is established, the link is not going to be fixed for a long time. Sometimes if the user is moving here and there will be a possible of disconnection happening. Okay. So that time the link failure issue will be occurring here. Okay. So link failure is nothing but when you are trying to transmit two different network devices. So sometimes if one of the devices is going out of the range, then the disconnection will be happening here. Okay. So this is about the general understanding about the protocol functionality. Okay. On the left hand side, you can see that as I said before, it's just going to send information to the destination based on the number of nodes that we call it as a number of intermediate nodes. Okay. So through the intermediates, we are going to forward the information. So in the table information, you can see that it has been mentioned that what is the node is given in the next process, and what is the weight is have been given on the every edges. Everything is mentioned over that. Okay. So this routing information will be passed to every node in order to get to know their neighboring details. Who is neighbor of mine, and similarly, who is the neighbor of the particular node, and this information will be keep on sending to the destination until it establishes the connection. Okay, I hope it's clear. So this is the basic understanding about the functionality of routing protocol. Okay, so now we'll just look back at the history of protocol, which is about the OSPF protocol. Okay, so why this specific topic I have taken is that because the OSPF protocol is the traditional protocol which has been introduced in the earlier of using of this internet connection. Okay, so I will just to give you the insight about what is OSPF protocol, who developed this, and who implemented this OSPF protocol. Okay, and this OSPF protocol, it stands for Open Shortest Path First. Okay, so what does it mean? Open shortest path first means when you want to establish your connection with the internet. Okay, so it has to find out the optimum path in order to transmit your information successfully. Okay, so this particular protocol, it has been implemented and developed by the set of people who are working in the IETF, that is about Internet Engineering Task Force. Okay, and then this particular protocol, later stage, it has been used for TCP/IP connection environment. Okay, so if you want to share some information among multiple users, you can use this OSPF connection, right? And similarly, here we have a different version of OSPF protocol. You can see here the first version of OSPF protocol is in the RFC document. So here the RFC is nothing but stands for request for comment. So whatever the protocol you are implementing and whatever the protocol you are trying to launch the networking field, right? So it has to be authorized by the set of people. So that's why this IETF and then RFC people are there to ensure that what is the capability of this particular protocol. Okay, and similarly here the version 2 and then version 3 also been introduced in the RFC 2328, and then the version 3 is introduced in the RFC the number 2740. Okay, so here you can see the version of OSPF protocol in connection with the RFC 2740. It uses the IPv6 protocol, right? So you know the difference between what is the difference between IPv4 and then IPv6, because if you take the Internet of Everything context, okay, so now the people are trying to connect billions and billions of devices to the internet. Okay, so here what the researchers have that with the IP4, that is Internet Protocol version 4, they will not be able to connect billions of devices. So that's why the researchers have found many things to be connected with the IPv6 protocol, so that it allows the users to connect the minimum length of 128-bit addresses with that. Okay, and then what is the another features? What is another salient feature of using this OSPF protocol is that it gives dynamic routing and then fast convergence, and then it provides a route authentication. So what does it mean? Dynamic routing means because it's not using the static routing, because the user is not going to be in the fixed position. So the user is supposed to move from one place to another place with their devices. Whether the devices can be anything, whether the users are using mobile phone or laptop or whatever it may be, right? So wherever they are moving, and then accordingly it should provide the seamless connectivity. So this is about dynamic routing. And then similarly, what do you mean by fast convergence? So here the fast convergence is nothing but in case if there is any link failure is happened, that means in the previous diagram I just to show you that when the transmission is going on, if there is any link failure is happening, so it has to identify the alternative path immediately without any delay. So that is about the fast convergence. And similarly, when you want to re-establish your connection with other devices, the route has to be authenticated by the node. That means your device itself, it should take the decision that whether the re-established connection is legitimate or illegitimate connection. So that has to be done properly. So these are the some of the points which has connection with the OSPF background. Okay. So now we'll just discuss about what is the link state algorithm, because here the link state algorithm is also is a part of the OSPF protocol. Okay, so if you look at the traditional algorithm like Dijkstra algorithm, so Dijkstra algorithms also uses the same concept, but here the functionality of the protocol is different here. Okay, so what we are seeing here in the link state algorithm, whenever you are trying to establish the connection with other nodes, so you have to share the link information with the other people. Let's say, for example, you just consider me as a source node. Okay, so if I want to send some packets to my neighboring node, I should give all my information to that neighboring node, so that the neighboring node, we are not sure whether the neighboring node will be a trustworthy person to give all my credentials or details. Sometimes the network context, it leads to some vulnerable attacks that we'll discuss what is happening in the security aspect. Okay, so whatever the information I have, it has to be given to the neighboring node, and similarly, all of the nodes will be doing the same process until it reaches the destination. Okay, I think this is a diagram will give you clear understanding about how these things are working here, right? So now here you can see here I have a set of computers which has been connected in a one single autonomous computer. Let's say, for example, here I have four different set of LAN connections. Okay, so I just taken this Oscf protocol, especially for the LAN connection here, right? So as you can see in this slide here, my LAN connection is having a group of computers, and similarly on the right hand side and below of the diagram, you can see it has been connected to one particular switches. Okay, so here what switches is just that it tries to connect all the devices together in one single point of time. That means within the particular autonomous system. Let's say, for example, if you take your SRM University or Christ University, all the devices will be connected to the one centralized point here, right? So now here in the animated things you can see here, now the left hand side system wants to send some information to the other system. Okay, so it uses the sorry for the inconvenience. Sir, am I audible now? Vignesh sir? Hello? Can you, anyone of you please respond in the chat, because I'm not sure whether I'm audible to you all of you. Yeah, thank you, Shalini, for this. Yeah, so this is how the communication is happening between the source to destination.
Okay? Yes, sir.
So, yeah, if one user
Yes,
wants
sir.
to send, if one user wants to send the information to other people, so they're supposed to use this router device to forward their information. Okay, and then so here I'm just showing you that how the link state algorithm is working with the Oscf protocol. Okay, so whenever I want to connect my devices with other devices, I just want to give my entire information to the neighboring nodes, so that the neighboring nodes will keep on sending the information to the other nodes or other devices. Okay, so in case what happens in case if the link failure is occurs, okay, in the first slide itself you have seen that in case if when the transmission is going on, if the link failure is occurred, so it has to re-establish the connection, and then you should keep on sending the information again and again for multiple times. And this is the functionality of the Oscf protocol. So now you can see in the diagram here, we have three different routers here. Okay, it uses a control packet called hello packet, because the each and every neighboring node wants to know that who is the neighbor of the particular node, so that it uses the hello packet to send the information. Okay, and here in the current era, when you are trying to configure devices with the internet, okay, especially now people are started to use the fiber internet connection cable, right? So here the fiber internet connection also, this Oscf protocol plays a vital role there, because here it uses a different dual ring topology here, because in the computer network context we have different types of network topology. We have a bus topology, topology, ring topology, so many things we have, right? And here, what is the advantage of using this FDDI thing is that here it uses the dual ring. Okay, so the first ring it is being used to connect with the network devices. Okay, so what is another use of the second dual ring is that in case of any failures is happen, that means if any link failure is happen, then it will take the alternative path to send the packet. So this is how the Oscf protocol is going to work here. Okay, so as I said before, it uses the hello protocol, or we can call it as a hello packet also. So what are the information will be available in the hello packet is that So when you want to identify the neighbor node, you have to give your privileges or you have to provide your information like router priority, and then you should tell about what is the router interval time, and then what is the list of neighbors around the particular node. Everything should be included or it will be uh, uh, associated in the particular allow packet. Okay, so based on this allow packet only, it's going to transmit the things over there, right? And then this information will be available in the link state protocol. Okay, so the link is nothing but if you want to establish a connection with a particular node, you will say it is a link. But that is a difference between a link and path. So link is nothing but if you want to establish a connection between two different nodes, it has become a link. If we can refer it as a link. But when you will say it is a path, the collection of links. Let's say, for example, if I'm a source node and then if I want to transmit some packets to my destination node, right? So between me and the destination node, there will be a collection of nodes will be there. So the collection of nodes and then collection of links will be known as the path here. Okay. So this is how the OS protocol is also does the job here, right? And here with the OSPF protocol, we use another type of algorithm is that SPF protocol. That is the shortest path first algorithm. So what does that mean? The shortest path first algorithm is that now it will be calculating the weight of the particular node. Let's say, for example, if I am sending some information to other node, so between me and the other node, I'll be calculating my cost of the two different nodes. Okay. So now I'm just calculating based on the bandwidth or maybe based on the distance, how far the particular node is placed from my side to that particular node like this. Okay. So based on this, it's going to select the path. It's like a first come first served based on the calculation. Okay. So I just show you one example for this also. Okay. So before that, what are the new features that have been added to the OSPF protocol is that here we have a different set of areas. Okay. I just tell you about because as with the given title, we are just going to see about how we can implement the concept of single and multiple areas, and then followed by we will see what is the router classification, and then OSPF router type, external route, and then equal cost multiple paths. So for that, right? So now this is what happening in the OSPF protocol. So we just look at this diagram. Here we have a different set of areas over there. Let's say, for example, here I have area 0, area 1, and then area 2, and similarly area 3 like this. Okay. So why I am classifying this is that because if number of users want to connect their devices with another devices, the router must be in the position to accommodate all the number of users. Okay. So they should not neglect their request. For example, if I am traveling in the bike or if I am traveling in the car, so if I want to use my mobile data, my mobile data wants to connect with my mobile tower. That means to the base station. Okay, but it happens through my mobile router one. So if I don't have a router, then I'll not be able to connect with my devices. So the best example is that you can take your Wi-Fi connection. So how your system is configured with the Wi-Fi connection. So unless or until if you are not having the Wi-Fi or wireless connection, you will not be able to connect with that. Okay. And similarly, what is happening here in the router is that when the plenty number of users want to connect with the devices, they cannot connect with a particular devices because it is not providing the scalable things. That means it leads to the scalability issue. Okay, so you know the meaning of scalability. So whatever the number of requests is coming from the different number of users, your router or your access point should give the service to them seamlessly. So that is about the different type of that is about the router. Here we are using a different areas of router here. So here I have just named it as the area 0, area 1, and then area 2, and then area 3 here. Okay. So here how I'm just classifying this area router is that here I'm just using the internal router, area border router, and then backbone router, and then autonomous system border router. So this is how I'm just classifying the type of routers in terms of IR, ABR, DR, and then ASDR. Okay, so you must know that what are the routes different types of router we are using here, because we might not be knowing about what is the router we are using in the Wi-Fi access point, all those things. But here we are having categorized different types of routers in terms of internal routers and then area border router, and then backbone, and then autonomous system border router. Okay, because the each and every router here, it does a different job. Let's say, for example, if you take the internal router, only within the organization will be able to connect with a particular router. And similarly, here you can see the area border router. So now just look at this diagram. In the middle of the diagram, I have a area 0. But in the top of the image, you can see area 2 and then area 3. So this will be considered the area border. Only these two type of area will be able to connect with the area 0. But here, what's the beauty of using this OSPF protocol is that here all the routers will be having the connection with the area 0, because this area 0 will be acting as a cluster head for all the routers. Okay. Even now, the recent developments have been shown tremendous effect in the field of telecommunication field, especially in the computer network field, right? Using this OSPF protocol, because with this OSPF protocol, you'll be able to use the concept of AI and the machine learning related things also. Automatically, it will be establishing the connection with the other devices, even if it is getting faded. Okay. So this is about the intra-area route. Okay. So what is happening in the intra-area router is that it is every routing functionality happening inside the particular area. Let's say, for example, if you take your SRM university, within that particular area, you'll be able to connect with that device. Okay. And similarly, the inter area is nothing but from different area to different area, you'll be able to connect with that. Let's say, for example, if you want to make a call from for your friend from one place to another friend. So this is how the inter area route is being used with the OSPF protocol. Okay. And similarly, the external route is also same, but here it is taking the connection from the autonomous system border. That means the ASPR. Okay, so these are the different types of routes here, right? And then we'll just look into the concept of implementing the external route here. Okay, so how the route is being calculated. So as you can see here, I have two different types of network. One is about the network 1 and then network 1 again. Okay, so what this is that it just to calculate the maximum cost for each and every link. Okay, so let's say, for example, now I have three routers, namely R1, R2, R3. Okay, so what it does is that it just to calculate the cost of every link. Let's say, for example, between the R1 and then R2 router, I have the cost calculation as 10. And similarly, you just look at that R1, between R1 and R3, the cost information is given as 8. So what is it representing that? Here, my OSPF protocol, since I'm using the OSPF protocol, it's just going to choose the best optimum path, which has the least cost here. Okay, so this is how the information is going to be passed to other information. So based on the overall cost, and it's going to select the path as the best path. So if you look at this two different paths here I just call it the cost value between R1 and then R3. So it's just providing the cost information as 8, so that this particular path will be taken as the shortest path to send my information. Okay, so this is type 1. But what is happening in the type 2 external metric is that, so in case if you are not adding any information, so in the previous example, what we have is we calculate the information. We just computed the value of what is the cost between R1 and then R2 routers. And similarly here, if I'm not adding any information, so what automatically what the OSPF protocol does is that it will select the best optimum path, which is calculated first in the routing table. So this is how the process goes in OSPF protocol. Okay. Yeah, and then now we just move on to the route authentication, because here if you take the security kind of parameter, it plays a vital role in all the domains, not only in the computer networks. If you take cyber security, if you take what is it, cloud computing. So here the security plays a vital role in all the domains. Okay, so here what is the use of this route authentication is that, because when you are trying to re-establish your connection with other devices, so it has to give the stable connection with the other devices without any security problem. That means it has to authorize that whether the particular node or the particular router or path is it's having a malicious node or not. So what is that meaning of malicious node? Because the malicious node, if you are trying to forward some packets to the other node, So the other node will not be forwarding the packets to the other node. It will be uh, keeping all the information within the particular node itself. So this is about the malicious node. Okay. So as we can see here in the second line, we are just discussing about the denial of service attack. So this is not happening in the computer network subject, not only in the computer network subject. As I said before, if you take cloud computing or if you take cyber security related things, it happens in all the domains. So what the cons of this denial of service attack is that in case if you are trying to pass some information to other people, it will not forward the information or it will not allow the users to connect with the devices. So it has to be checked well and it has to be authenticated in such a manner, right? So this is about the root authentication. So now we just come to the next part of this session is about how we can implement this OSPF protocol for single and multiple area. Okay. So because in the previous diagram, I was just showing you of what are the different types of routers we are using in the computer network, especially in the OSPF protocol. So here, what is the disadvantages we are facing in the single area and why we have migrated from single area to OSPF protocol? I mean, single area to multiple area. Okay, so because the devices, because we are trying to connect our things with the internet through our mobile phone or through our laptop, or we'll be using our personal computer. So what are the thing is happening in the single area OSPF protocol is that it has a large number of information to be processed from source to destination. That means every time, every periodical time, it has to update the information. Okay, let's say for example, if I'm updating my table every 1 second or 2 seconds, so it has to update the information very meticulously to forward my information. Okay, so unless or until if it is not forwarding the information to the other node, so that the information will not be reached out to the destination properly. Okay, so that's why this single area deals with this kind of problem. So there will be a large routing table because since our devices are very tiny, the memory space also will be a little bit minimum. We will not be able to store a huge information to be processed within the tiny devices or caches which we are using. So that's why we have migrated to another type of OSPF protocol that is about multi-area open short first algorithm. Okay. So here, as I said before, what I'm going to do with this multi-area, here I'm going to create a different set of areas in terms of area 1, area 0, or area 2 like this. Okay, so that I'll be able to accommodate more number of devices, which will be establishing the connection with a particular router, so that my connection will be very smoother. That means I'll be able to send my information seamlessly without any link breakage or link failure. Okay, so this is the main advantage of using the multi-area OSPF protocol, right? And here we have a two-layer area hierarchy. Okay, so here the multi-area OSPF protocol, here we have two different type of area. One is that backbone area, another one is the regular non-back, that is about regular area, non-backbone area. Okay, so let's say for example, if you want to connect with the other devices, so here we have segregated the type of areas in terms of area 0, area 1, and then area 2 like this, and so on, right? And then what is happening in the backbone network is that whatever the connection, whatever the devices wants to connect with the particular devices, it has to be connected with the area 0. Okay, so because the area 0 will be acting as a centralized router here. So if you are trying to transmit some packets or some information through this area only, you will be able to connect with it. Otherwise, you will not be able to connect with it. Okay. And similarly, here, what is happening in the regular area is that is about non-backbone area. So whatever the devices which have been connected in a different area, so you will be able to connect with the particular area, and similarly, you'll be able to connect with the area 0. Okay. So this is a two-layer hierarchy with respect to the OSPF protocol. And here I'm just showing you that different types of LSA type, which start from LSA type 1 to 11 here. Okay. Just look at this. What is given in the LSA type 1 is that a router LSA, and similarly we have a network LSA, and similarly we have a summary LSA like this. Okay. Yeah. So now you just look at this diagram for better understanding about where this OSPF protocol can be used or can be deployed for giving the uninterrupted services, right? So now here I have classified the area types in terms of LSA 1, 2, 3, 4, 5, 7 like this. Okay, because here I have not used the version of 6 here because the version of 6 here is not been introduced or implemented. That's why the Oscf protocol is introduced up to LSA 7. Okay, and similarly here you can see the different types of area here. You can see the backbone area and then non-backbone area, and similarly here the sub area and then totally sub area, and similarly here we have one more area called non-source sub area. So what does it mean, this table, what is it representing here? That in case if I want to connect with the backbone area, okay, so here with the backbone area, almost all the connection will be uh, established with the area 0. Only the LSA A7 will not be able to connect with that. That's why it is being mentioned as a value of no here, because it will say whether it is a yes or no. And similarly, if you want to connect with the non-backbone area, that is the regular area, so here in all the column it's being mentioned as a yes, yes, yes. Only the LSA 7 will not be able to connect with that. Okay, because this OSA protocol will be limited in usage. That means which will not be used for all the places wherever you want to establish this connection. Only this particular protocol specifically well suited for this type of areas, including the backbone area and then non-backbone area only. So that's why in first 5 places it's been mentioned as a SSS maximum. Okay, maybe if you look at the LSA 1, in all the places it's been mentioned as a LSA 1 because this LSA 1 will be having the direct connection with the area 1. I mean the area. The different types of OSPF protocol we are looking in the computer network slide. And then here we have a different set of operations here. Okay, so if you take the multi-area OSPF protocol, it has different types of functionalities or features of its own. Okay, so if you look at the type 1, okay, so here we have 5 different types of OSPF protocol. So each and every type it does a different job here. Okay, so what you are looking in the type 1 is that, so if you want to share the information within the particular organization or within the particular group of people, you'll be able to connect with the devices. Let's say, for example, better example is that we can take up our Wi-Fi connection within the campus, right? So this is about the type 1. And similarly, here you can see that what is happening in the type 2 is that it has some salient feature of its own. So what is happening? Only it will be collecting the information within the particular area, but which encompasses all the parameters, like it is just collecting the information about the router ID and then IP address of all the routers, so that this information will be shared with the other type of devices, so that the next device will be keep on sending the information until it reaches to the destination. This is about type 2. And then what is happening in the type 3 is that only whatever the nodes are available in the ABR category. So because in the starting of the slides, we have seen the different types of gateway protocol, right? So in which we have seen about what is the ABR, right? That is the area border router. Whatever the nodes are distributed in the ABR level, only those information will be available in the LSA type 2. Okay, so this is how the process will be going on until it reaches to the destination. Also, here we will be able to authenticate the nodes. Let's say, for example, now in this diagram, you can see that here we have three different areas in terms of area 0 and then area 1 and then area 2. So let's say, for example, either now area 1 router wants to communicate with the area 2, or area 2 wants to communicate with the area 1. So through this intermediate router only, they'll be able to communicate. So this is what I'm trying to say, the LSA, I mean the OSPF protocol in all the types of things. Okay. So whatever the nodes or whatever the routers wants to communicate with that, it uses the intermediate connection to forward the information. As you can see here in the diagram very clearly, right? Yeah. And then what is happening in the LSA type 4 is that, so LSA, you know that link state advertisement. So that means that each and every protocol, it gives the information to the other nodes who keep on sending the information to other nodes to reach the destination node. Okay, so what is happening in here in the type 4 is that it just takes the only the nodes information only from the ASDR. That is about the autonomous system border gateway protocol. So whatever the nodes are replicated or whatever the nodes are distributed in the only particular border gateway protocol, only those will be considered for the establishing the communication. Okay, so this is about the OSPF protocol type 4. And then what is happening in the type 5 is that here it just take out the information from the external routers. I mean, what I'm trying to say is that in case if you want to share the information from the other participants, okay. Let's say, for example, now if I want to make a phone call, one of my friends, okay. So I'm right now I'm in Bangalore. In case if I want to make a call, who is in Chennai now, right? So he'll be attached to the different mobile station or base station. Okay. So in case if I'm trying to make a video call through any one of the apps, right? I should be able to connect with the internet through any one of the protocols, right? So whenever I'm trying to connect with my friend through the particular app, since I'm calling from Bangalore to Chennai, it uses the multiple channels for this. Okay, so the channel, multiple channel is nothing but here it is not going to use only the single channel for delivering my information. It uses the multiple channels so that since I'm calling from Bangalore, my call will be considered as the external LSA entries. That means the particular person is not belonging to the current state. Maybe if you guys are in Tamil Nadu, right? So since I'm in Bangalore, this is a different state. It uses a different set of connection for establishing the connection. So that's why my connection will be considered as the external connection here, right? So this is how the process goes like this in the all the type of OSPF protocol, right? But in the all the types of OSPF protocol, what we are looking, the unique feature is that whatever the protocol, I mean, whatever the connection, different types of LSA protocol you are using, it is connection with one unique feature is that it uses the common gateway protocol for sending all the information through the area 0, right? So this is all about the different types of LSA type 1, 2, 3, 4, 5. Okay, and this is why the researchers is also focusing on this type of multi-area OSPF protocol rather than taking the single area OSPF protocol. Okay, yeah, and then the next thing is about the configuration of multi-area OSPF protocol. Because I just browsed about this things how we can show the demonstration of this OSPF protocol. Since the things are not open source, I'm not able to demonstrate that. But we can show the things how things are happening in the respective OSPF protocol through different simulation tools. You can NS2 tool, and then you can use some Cisco packet tool, and then you'll be able to configure this how the things are happening here. So this is about the implementing the multi-area OSPF protocol. Okay. So here I just need to mention that how many routers I'm going to use, what are the different parameters I'm going to choose for my OSPF protocol. Everything will be able to mention with that, right? And then here this is how the router configuration also will be showing that. Right? So when I'm using different types of area here, such as the area 0, 1, 2, right, I can ensure that how it is being connected with different places. From the right hand side on the command prompt, you can see that what are the information is available in the area 0 and area 1 also. It will show you the IP address of the particular router because each router will be having the unique ID that how it is transmitting the information to the other node. Okay. And similarly, in the OSPF 3 protocol, you can see that since it uses the IPv6 protocol functionality, it connects the information with the it shares the information with the other routers. Similarly, for n number of devices can be connected with them because we are using the IPv6 protocol here, right? Yeah, and then also we'll be able to verify the neighbors to which my router is being connected, right? So I can show up the things, who is my neighbor and what protocol I'm using and what are the type of database it uses, whether it's a link state protocol or shortest path first algorithm. Everything will be visible in the particular OSPF version 2 protocol, right? So this is all about the implementation of OSPF protocol with the different types, and we are just moving on to the next part, that is about the authentication. I think I won't be taking much time to tell about this. This authentication is not only for the issue, only for the OSPF protocol. This authentication of the things, I mean, when you want to connect with your device with a particular router, it leads to various attacks also. I just tell you about in the overall diagram what are the issues that we are facing in the research context also, right? So here, if you look at this OSPF support, here the two types of authentication will be done here with respect to the open shortest path, the first algorithm. One is that whatever the information you are trying to send through the particular router, it has to be forwarded to the next node without changing any values or without modifying any information over there. So whatever the plain text you are giving, so that will be converted as ciphertext, and then later stage you'll be getting your original plain text. So this is how the encryption decryption process is happening here. Let's say, for example, one way is that whatever the information we are sending, that will be given with some password authentication. Let's say, for example, if I'm sending my information to other node, I'll be giving the set of passwords to my other node, because the other node wants to reveal the things from my side. I mean, whatever the password I gave it to him, so he has to check the password, whether the password is valid or invalid. Okay. So in case if any malicious node, if there is any intruders are present in the particular network, so they will not be able to go again with the communication. So this is how the process is happening in the security kind of aspects, right? So here in the OSCF protocol, earlier they were using the algorithm, this type of algorithm, that is about MD5. The MD5 means this is about message digest file. This, I mean, the digital algorithm and with the many things, right? Now, the current era, the researchers are started to use the different types of I mean, what is it? Different types of authentication algorithm, including the RFC algorithm and then other types of algorithm also. So in the earlier, when the OSCF protocol was introduced, that time the people started to use this MD5 authentication algorithm, because this MD5 authentication is not also well suited authentication mechanism for this type of protocol, right? Because every time whenever the router generates the packet, it has to check for the valid credentials, whether the particular route is having all the credentials or not. In case all the credentials are not same, then the routers, the devices will not forward information to the next node. Okay. So the best example we can take it up. What is it? The banking sector. So whenever you want to create a new account in the bank, right? So the people, the employee of the bank will be checking your credentials. And demonstrated with the help of NetSim tool. So there is a tool called NetSim tool, but this is not a free of cost. In case if your institution or if your friends are using this in a prestigious institution like NIT or IIT, you can see the things also. So here, what you can see here, the router, once your router is configured with that, you need to give the password for this. So the password, you need to give the authentication things also. That means the password will become the authentication. If the things are clear, then you will be able to find other router. Similarly, for every router, you need to give the password things, or you need to give the password credentials to connect with the particular device. So why this algorithms, I mean, authentication is required in the multi-area OSPF protocol is that since we are using a different multiple devices to connect together, right? So we cannot ensure that all the routers or all the nodes will be genuine users or genuine nodes. So in order to check that whether the particular router is genuine or not genuine, we are giving this type of plain text context. That means we are giving such type of authentication mechanism so that whenever the link failure is happening, So when it re-establishes the connection, based on this authentication thing, the thing will be solved out. That means the issue will be rectified out. Okay. So this is how the process is going in the security aspect of. Okay. So now we just look at this example here. I just mean of loopback is that it's just what is it? It is just to ensure that whether the redundant information is happening um, for multiple times again and again. Let's say, for example, once you pass the information, the same information will not be available in the routing information. But in case of any intruder is coming to their network, and then if they are trying to damage your router, then same information will be replicated for multiple times again and again. So that's why we are using this loop back parameter in order to ensure that there should not be any redundant information in the routing table. Okay. And then now you can see that verifying the plain text password and authentication. So using this set of commands, you can verify that who is my neighbor and what is the route my particular area has chosen, and followed by you just click on that options called ping. I think I just want to tell you about this ping concept also. Let's say, for example, if you are, I think just go with this one example here. I'm just opening up my I hope it's visible, right? Yeah. So now, if you want to identify the IP address of the particular institution or particular the industry, so what you can do is that you can use the command called ping. Okay. So if you use this ping command, okay. So if you know the IP address of the particular institution or a particular organization, you can directly give that particular IP address of the ping. Let's say, for example, I'm just giving 192.168.1.1 like this, right? So that it will be just showing that what type of protocol I'm using with that. You can see the information, what are the information are coming out now, right? And since I'm using the ICMP protocol, it's just giving the sequence number which starts from 0 to, and then it goes on for some time. Okay, so it has the capacity of bringing the information of 56 data bytes here. Okay, so this is one way. Otherwise, if you want to know about your what is it IP address of your institution, you can use the ping command and followed by your institution website address. Let's say, for example, www.christuniversity.in. When you give this kind of information, then you will be able to find out that what is the values generated, what is the total number of data bytes, and also it will be showing that the TTL value here, right? So the TTL value, what does it mean here? It says that it's time to live. So how long time my information is going to be available for some time in the network. So this is how you'll be able to find out the things here, right? And then just coming back to the question again. Yeah. So this is about verifying the authentication, and also you'll be able to verify that using the ping command. So using this ping command, you'll be able to reach out the destination, whether the particular site is available or not also. So in case if the particular site is not available, then you will be able to ensure that the particular website is not completely registered with that, right? So this is how we can verify using the ping command also, right? And then at the at the end, we just look at some of the challenges which we are facing in the TCP/IP layer, especially. Okay, so here we are not just looking at the OSCF protocol in terms of all the OSA layer, because if you look at the OSA reference model, you might be studying about all the 7 layers from physical to application layer. Now here, which we are looking in only the 4 different types of layer, because in connection with the TCP/IP layer, we call it the internet layer. Since we are connecting the devices with the internet, only we'll be able to give the solution for all this type of layers, whatever I'm showing here now, right? Which starts from physical, data, network, and then application layer also. Okay. So here, these are the physical, data, network, and application is widely applicable for all the layers. I mean, all the types of network, whether it is a wired or wireless, it doesn't matter about that, right? But when you look at this type of protocol, which I have shown in the next phase of the diagram, is that it just shows the understanding about what is the difference about proactive, reactive, and then hybrid here. Okay. So here the proactive protocol, when we use this type of protocol, especially for the wireless network, so this particular protocol is coming to exit is coming to the action. That means whatever the information you are transmitting, every information will be maintained in the particular table. So every time you have to give the table to the other people, I mean to the neighboring nodes. And similarly here we have a reactive protocol. Whenever the connection is required, only that time we will be able to connect with that, right? Also here we need this particular protocol leads to different issues as we can see here, right? So this particular proactive protocol leads to different security aspects. Maybe as we discussed earlier, it leads to denial of service attack, and sometimes it leads to confidentiality attacks and then integrity issue, and many things are happening here, right? And similarly, it leads to some of the network attacks. Let's say, for example, if you take network attacks, whenever you are being connected with your internet, knowingly or unknowingly, you'll be trying to launch some software on your devices. So automatically, in which in turn it leads to different network attacks. You can say you can just look at the different types of attacks like a sinkhole attack, wormhole attack. So this will be considered as a network attack here. Okay, and then what is happening in the quality of service is that here the quality of service ensures the connection performance. That means it just give you the user satisfaction based on these two parameters. Okay, so one type of quality service parameter is that quantitative, another type of parameter is that qualitative. Okay, so that is the difference between quantitative and then qualitative. Okay, so whatever the things you can consider the quantitative parameter, right? And similarly here, whatever the things can be measured through the performance. Let's say, for example, if you want to measure the performance of a particular node based on the reliability, scalability, and then security, this will be considered as a qualitative parameter. And similarly here, whatever the things you can be measured in terms of number, that will be considered as a quantitative. So the best example is that you can take up the bandwidth, right? So if I ask you what is the bandwidth of your Wi-Fi home network, you will say that this is providing 1 Mbps speed or 2 Mbps speed and so on, right? And similarly here, it leads to some of the challenges like a delay, right? So here the delay is one of the most considered parameter for the network kind of research, because whenever you are trying to transmit some information, it should not take much delay to transmit all the information from source to destination, right? So it has to disseminate all the information with a minimum delay. Okay, and similarly we are looking in the energy. Okay, so now all the researchers are focused on this type of parameters, especially in the energy level consumption, right? So whenever the energy is consuming more and more, then you will not be able to connect with the devices, because all our wireless devices are running on the boundary power, right? So this is a challenge we are facing in the wireless type of network. Okay, because in the wired network it's not a problem, because we will be having a direct power connectivity with our system and to the black point. Not at all issue with the wired network. But when it comes to the wireless type of network, it uses, it consumes a lot of power in order to transmit all the information into that, right? So these are the certain issues which we are dealing with the computer network context, especially in the internet layer. Okay. So now I just want to tell you about what is the same thing is happening in the cyber security related things also, right? And similarly here you can see that what is the main issue happening in the network layer is that link failure. So this is what I was showing you in the beginning of the seminar itself, right? So whenever you are trying to connect things with your devices, so we cannot ensure that our connection will not be able to connect with the Wi-Fi, or we will not be able to connect with the mobile tower also. Okay, so this type of link failure, we cannot avoid it entirely, but we will be able to reduce it as much possible by identifying the certain things through some uh, technical challenges. Like because if you want to remove the intruder node, or if you want to remove the malicious node which is present in the network, okay. So in case if the malicious node are also present in the network, they will cause the damage like the link failure. So they will deliberately they will be sending some fake information to the other nodes that I am the best node, so that the entire transmission will be collapsed. Okay, so that it leads to many issues like congestion and then collision. This type of issue also will be likely to be occurred. Okay, that's why the research is going on this particular link failure related thing also. Okay, because if the link failure is if we are able to control as much possible, then we'll be able to give uninterrupted service to the people also, right? So I think I'm done with my presentation. So I hope I given some insights about what is the functionality of OSL protocol, and then we just seen what is the difference between the single and then multiple area, and then we have seen different types of gateway also, right? So I guys, I hope I given more insights onto this particular topic. Since you guys are in final year of UG, right? So you try to explore more on this particular computer network related things. Okay, so because there have been different parts of it, because if you see the computer network as one point, it is a big ocean, right? Because in the computer network itself, we have a variety of different domains. We can, if you look at the wireless devices, it uses a different things. If you look at the wired net type of network, it uses a different procedures, and then it uses different semantics for this also, right? But if you concentrate on any particular thing, you try to explore more on this part, so that you'll be able to enrich your knowledge on the particular part also, right? So maybe thank you for the opportunity once again. If you have any doubts, you can ask me. Otherwise, you can ping me also on my WhatsApp number. Also, I have given my official address of my email ID. You just note it down and write back to me anytime. So if I see your mail immediately, I'll be responding back. And if any queries related to this, you can ask me. I hope there won't be any queries related to OSCF protocol. If there is any queries related to computer networks also, you can ask me now. Yeah, thank you. So over to Uday sir or Vignesh sir, you can take up.
Sir, thank you, sir. Thank you, sir. Participants, if you have any queries, you can contact the resource person. You can unmute yourself and you can ask the resource person. Participants, we have given an unmute access. You can unmute yourself. You can ask your queries. Thank you, sir. Thank you, sir. Participants, if you have any queries, you can contact the resource.
So if there is no queries in the chat, I can assume that no people have listened to my lecture. At least I'm expecting one or couple of questions from your side, maybe related to computer network, or maybe in general how the research can be done in the different types of network. Also, you can ask me something related to this. I hope no queries. Can you at least respond in the chat whether you have queries or having queries or not?
Yes, participants, if you have any queries, you can post your queries in chat box, or else you can unmute yourself and you can ask your queries. Sir, I think there is no queries from the audience. I think so, sir.
Yes, sir. That's fine. Thank you.
Okay. Okay. I now call upon Mr. A. Vignesh to propose the vote of thanks for the session.
Good evening, everyone. I'm happy and thankful for allowing me to deliver vote of thanks of this wonderful gesture. I extend my sincere thanks to the management for encouraging us to conduct these types of events, and my grateful thanks to our respected director, SRM Institute of Science and Technology, Ramapuram campus, for his support and guidance. My special thanks to the speaker of the day, Dr. Nishman Rio, for the wonderful limelighted session today. And in spite of his busy schedule, he accepted our respect to raise this occasion. Thank you, sir. My sincere thanks to mention to our respected Dean, SNDH, SRM of Science and Technology, Ramapuram campus for his dynamic support, guidance, and advice. I would like to acknowledge and thank Dr. S. Umarani, Professor at Convergence Department, for our continuous effort in making this event a grand success. I'm thankful to allow I'm thankful to all the participants for joining this event to attend the session. I hope you are all learned. Thank you all once again. Thank you, sir.
Yeah,
Nisman sir,
thank
I have
you.
only one queries from the audience, sir. I think
Yes,
one
yes, sir.
student text in my WhatsApp. The
Yeah.
student is using MacBook actually. Is there is any open source tool for Cisco, any networking devices to for practicals for MacBook?
No, sir. For MacBook, they want to use it for computer network, right?
Yes, yes, sir. Yes, sir.
No,
Currently,
actually,
they are
that is.
using in college. They are using Cisco Packet Tracer. So the
Yeah,
student
yeah,
is using MacBook Air. So is there is any alternate tool
yes, sir.
for?
Is that there is a software for this MacBook also. So the only thing is that they are supposed to use that kind of. I mean, they're supposed to use based on the system configuration. Let's say, for example, now they might have installed it on Windows operating system. Similarly, there have been different softwares which is available for Mac OS also. The thing is that they need to find out the software based on the compatibility of their system, so that they can use it also. Because I was using with the Cisco packet tracer with the extension of DMD something, right? So similarly
Okay,
for
okay, okay.
MacBook, it uses a different version of this. They can use it, but here what is the thing is that they can go with what is that Cisco packet tracer, that is fine. And similarly here they can use with some virtual lab also. It is available
Okay,
in
okay,
the
fine.
internet also. They can use it. Yeah.
Okay, sir. Okay, okay. Thank you, sir. I just convey this
Thank you.
message to them. Okay,
Yes,
thank you, sir.
thank you so much.
Thank you, Nisman sir. Thank you for this
Yeah,
wonderful
thank
session.
you.
Thank you, sir.
Thank you.